Hello students, welcome to the session. So see here, in the last class we have completed the whole syllabus of the first PUC topics. Then we have seen the last chapter waves, is it right or not? Including the classroom assignment as well as the home assignment numerical problems. I hope everyone has understood these questions, and if we have any doubt, please go through it once again. So definitely we can understand each and every step of the numerical problems. Okay. In today's session, ಇವತ್ತಿನ ಸೆಷನ್ ನಲ್ಲಿ ನಾವು we are going to start about the second PUC syllabus. You all know that for our KCET examination, second PUC plays a very important role, and those who have neglected the first PUC, my request to please concentrate on the second PUC. Minimum we can score a 35 to 40 marks from this part, that is second PUC syllabus part ಅಂತ ನಾನು ಹೇಳಕ್ ಇಷ್ಟ ಪಡ್ತೀನಿ. And in this second PUC first chapter, second chapter, third chapter and fourth chapter, if you prepare for these four chapters, definitely I am saying that you can easily answer minimum of 16 questions, or minimum of 13 to 15 questions you will get it in the ಫೈನಲ್ ಎಕ್ಸಾಮಿನೇಷನ್. ಸೊ ಡೋಂಟ್ ನೆಗ್ಲೆಕ್ಟ್ ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ಈ 4 ಚಾಪ್ಟರ್ನ ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡೋಕ್ಕೆ ಹೋಗಬೇಡಿ. ಓಕೆ, ಸೊ ಪ್ಲೀಸ್ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ, ಪ್ರಿಪೇರ್ ಆಗಿ, ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ ಆಸ್ ಮೆನಿ ಕ್ವಶನ್ಸ್ ಆಸ್ ಪಾಸಿಬಲ್. So whatever the points required to solve the questions from these chapters, we will explain to you those important points. So concentrate and prepare. So in this session we are going to discuss about the important points related to the electric charges and fields. Here related to electric charges and fields. What are those points? So I will explain in a short and sweet manner. So please concentrate and learn it here. So what is a charge? Charge is nothing but it is a basic property. It is a basic property. Don't neglect definitions also. Based on definition also we can expect the theory question. Basic property associated by the fundamental particles like electron, proton, alpha particle, okay, beta particle, like that. We can expect we can define the charge. And later we have to understand that charge is a scalar quantity. It is not a vector. It has only magnitude. And let us see here, there are two types of charges. Charges. What are they? See here, first one, it is a positive charge. And second one is a negative charge. And please make sure about this. When we can say a body is a positively charged body, when we can say a body is a positively charged body. So very simple. When a body loses electrons, when the body loses electrons, okay, then it will become positively charged body. Is it clear? I hope you are understanding the points. And second one, whenever we go with this negatively charged body, how can you define this negatively charged body here? Negatively charged body. So very simple. ನೋಡಿ ಇಲ್ಲಿ ಯಾವ ಬಾಡಿ ಆದರೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ನ ಲೂಸ್ ಮಾಡಿಕೊಳ್ಳುತ್ತೋ ಅದನ್ನು ಪಾಸಿಟಿವ್ಲಿ ಚಾರ್ಜ್ಡ್ ಬಾಡಿ ಅಂತ ಹೇಳ್ತಾರೆ. ಯಾವ ಬಾಡಿ ಆದರೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ನ ಗೇನ್ ಮಾಡಿಕೊಳ್ಳುತ್ತೋ, ಇಲ್ಲ ದ ಬಾಡಿ ವಿಚ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ಎಕ್ಸೆಸ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಓಕೆ, a body with excess number of electrons. A body with excess number of electrons is said to be a negatively charged body. Later we have to concentrate on the important properties of the charge here. What are the important properties? Important properties. First one we can say charge is conserved. First one we can say charge is conserved. What is the meaning of that? Charge neither be created nor be destroyed, but it can be transferred from one body to another body. That means charge remains constant. Charge remains constant. And second one we can say that charge is quantized. Charge is said to be quantized. What is the meaning of this quantization here? Means we can say Q is equals to plus or minus n into a, where n is a natural number, when n is a positive integer ಅಂತ ಹೇಳ್ಬೋದು. E is the electronic charge E is called as electronic charge, and its value is 1.6 into 10 to the power of minus 19 coulomb. 1.6 into 10 to the power of minus 19 coulomb. And in the nature the electronic charge is the smallest charge. That means there will be no charge having the magnitude less than this electronic charge. Please make a point about this here. And third one we can say that charge is additive in nature. Charge is additive in nature. What is the meaning of that? Suppose whenever we consider a system of charges q1 q2 plus q1 so on qn, then the total charge system can be written as q1 plus or minus q2 plus or minus q3 plus or minus so on plus or minus qn. Okay, this is the total charge of a body. Our charge is always additive in nature. Later we can go with a normal property, that is we can say like charges repel each other, and unlike charges attract each other. Okay, so like that we have to understand the important properties of the charges. Later we can say that the nature of the charge can be known or can be determined. Nature of the charge can be determined with the device called ಏನಂತ ಕರಿತೀವಿ ನಾವು ಅಂತಂದಾಗ we can say it is electroscope ಅಂತ ಹೇಳ್ತಾರೆ. We can call it as electroscope. It is a device used to detect whether the body is a positively charged body or a negatively charged body. Okay, are you following, Nova? Later we can say that or how can we charge a body, not produce, how can we charge a body? Methods of charging a body. What are the different types of methods of charging here? First one we can say that by conduction. Okay, how can you define this conduction here? Conduction, so please observe this here. Conduction, see here, the process of charging a body. So based on the definitions or based on the sentences also, we can expect the theory question. The process of charging a body, okay, by bringing a charged body in contact with a neutral body. Okay, that is called as what is conduction process. So see here, observe the diagram carefully. Whenever we consider a neutral body or uncharged body, and whenever we bring either it may be positively charged body or negatively charged body, and in contact with the uncharged body, then the uncharged body or neutral body will acquire the same charge of the body which is placed in contact. Okay, like that we have to understand about the conduction phenomena. Okay, and let us see one second one, by induction. So what is the meaning of this induction? So see here, the process of charging a body, the process of charging a body by by bringing a charged body, near to it, but not in contact, okay, is called as what is it, induction phenomena. So just observe the diagram here. This is a neutral body. Let us assume this is a neutral body, and whenever we bring a positively charged rod or positively charged body near to this neutral but not in contact, then we can say that oppositely charged or opposite charge will be induced on the surface of this neutral body. This is how we can charge a body. And second one, and third one, by friction. So what is happening in friction here? When one body is rubbed, when one body is rubbed against, when one body is rubbed against another body, the charges are produced or the body will become charged. See here, whenever we consider two bodies or two neutral bodies, and whenever we rub one body over the other body, what happens means there will be a transfer of electrons from one body to another body. The body which loses electrons will become positively charged body, and the body which gains electrons will become negatively charged body. Okay, like that we can produce, or we can have the process of charging of a body by three different methods. One is conduction, induction, and the other one is friction. Okay, later we can go with see here, what is the Coulomb's law? Coulomb's law. What the Coulomb's law states? So see here, whenever we consider the two charges, let us say Q1 and Q2, separated by some distance r, we can say there will be a force of attraction or force of repulsion. Simply we can call it as electrostatic force. And if we denote F as the electrostatic force, and it will be proportional to product of magnitude of the two charges and inversely proportional to the square of the distance. By combining these two, we can write that 1 by 4 pi epsilon naught into Q1 Q2 divided by R square. 1 by 4 pi epsilon naught into Q1 Q2 by R square. What is this 1 by 4 pi epsilon naught? It is a constant of proportionality, and its value is 9 into 10 to the power of 9 Newton meter square per coulomb square ಅಂತ ನಾವು ಹೇಳಬಹುದು. And what is this epsilon naught? Epsilon naught value is 8.854 into 10 to the power of -12 coulomb square per Newton per meter square. And we call this epsilon naught as absolute permittivity. Or permittivity of a free space. Okay, I hope you are understanding my here. So you have to remember this value, because in while solving the numericals, these values will not be given to you. Okay, so this is in place of in air medium. Okay, and whenever we go with in any other medium, we can say the force can be written as 1 by 4 pi epsilon Q1 Q2 divided by R square. What is epsilon called here? Epsilon is nothing but epsilon naught into epsilon R. So it is called as permittivity of a medium, permittivity of a medium, permittivity of a medium, and epsilon r is also called as the dielectric constant, and it is defined as the ratio of permittivity of a medium to permittivity of a free space. Here it is we have to understand each and every relation, because based on the formulas also we can expect the numerical questions. Is it right? We call this as relative permittivity, relative permittivity. Okay, so please make sure about this here. So like that we can write the force is equals to 1 by 4 pi epsilon naught into epsilon r, epsilon naught into epsilon r into q1 q2 divided by r square, q1 q2 divided by r square. Is it right? Like that we have to think, and we have to write the, and we have to analyze the Coulomb's law in different cases. Later we can go with let us say this is a f medium, this is f medium, medium. So whenever we take the ratio here, whenever we take the ratio to get the epsilon r, dielectric constant or epsilon r can be written as f naught, that is air medium, f medium, any other medium. It is defined as the ratio of the force between the two charges in air medium to the force between the two charges in the given medium. So this is the important about the what is the dielectric constant or relative permittivity, relative permittivity. Okay. So how to write? How to write the Coulomb's law? How to write the Coulomb's law? Coulomb's law in vector form, in vector form. So please make sure about this. What is the Coulomb's law in vector form? Let us consider the two charges q1 and q2, and the distance between them. Let us represent the distance between them is r12, which is equals to minus r21 in vector representation here. The q2 will experience a force. See here, f21 vector, and q1 will experience a force we can say f12. So in vector form we can write see here, f21 vector is equals to 1 by 4 pi epsilon naught into q1 q2 divided by r21 square into r21 cap. Otherwise we can write f21 vector is equals to 1 by 4 pi epsilon naught into q1 q2 divided by r21 cube into r21 vector. So please observe and concentrate how we are writing the Coulomb's law, or how we are writing the electrostatic force in vector form. Please make sure about this. If we get a unit vector, then in the denominator we get only square. If we get a vector, then in the denominator there will be cube. There will be cube. So see here an important point. It is repeated, and it is asked in the previous year's papers also. See here, whenever we consider the two charges separated by some distance r, let us say, and whenever we place a dielectric, let us say, of thickness t and having the dielectric constant k, then we have to understand that effective distance between the two charges will become equals to r minus t plus t root k, r minus t plus t root k. Therefore what happens to the force between them? Force becomes equals to 1 by 4 pi epsilon naught into q1 q2 divided by r equivalent square, okay. So this is how we can write the what is the force or Coulomb force between the two charges. Okay. I hope you understood this point here. Now let us go with the next concept. That is electric field. What is this electric field? How can you understand this electric field? Okay, electric field in the sense, let us understand the definition of this. Whenever we consider a charge, around the charge, there will be some region in the space up to which the charge will show its effect, or charge will show its force of attraction or repulsion. That is called as a electric field. the region around a charge, the region around a charge up to which, the region around a charge up to which the charge will show its effect is called as electric field. Now let us understand what is the meaning of electric field intensity here. What is the electric field intensity? Usually denoted by E vector. So it is defined as, ಹೇಗೆ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ ನೋಡಿ ಇಲ್ಲಿ, electric field is always equals to force acting per unit charge. And see here, whenever the electric field always acts in the direction of the force. See here, what is the SI unit here? SI unit of electric field intensity is, we can say, Newton per Coulomb. And observe this, it is a vector quantity. Electric field intensity is a vector quantity. Please make sure about this, it's a vector quantity. And later we can say that whenever we know the electric field intensity at a point, and how to calculate the force, we can say F is equals to E vector into Q naught. Okay. So that is about the electric field intensity. Later we can say that what is the electric field? What is the electric field due to a point charge? So what is electric field due to a point charge? For example, whenever we consider a charge Q, and if I want to know what is the field at a point P at a distance of r, then we can say electric field is equals to 1 by 4 pi epsilon naught into Q divided by R square. And please make sure about this, the formula is very, very important. And from this we have to understand that electric field intensity is directly proportional to the charge and inversely proportional to the square of the distance. Okay. Later we have to understand about the what is the principle of superposition here. Principle of superposition. So see here, whenever we are having a group of charges like Q1, Q2, Q3, so on, Q1, we can say let P be a point, which is at a distance of R1 and which is a distance of R2, which is a distance of R3, similarly at a distance of Rn. Then according to principle of superposition, we can write E vector is equals to E1 vector plus E2 vector plus E3 vector plus so on, En vector. That is how we can apply the principle of superposition. Is it clear? And suppose, for example, I will make a note here. Let us say there is a charge. Let us say there are 2 or 3 charges. For simplicity, let us consider only 2 charge. Let P be a point. Due to the charge, see here, one field is directed as shown in the figure, and other field is directed as shown in the figure. And if these two electric fields we are inclined by an angle theta, then the resultant ER is always equals to, see here, ER is equals to square root of E1 square plus E2 square plus 2 E1 E2 cos theta. Okay. So this is a very, very important formula to find the resultant electric field of the two fields. Okay. What is the theta here? Theta is the angle between. Okay. ಇಲ್ಲಿ ಸರಿಯಾಗಿ ಕಾಣಿಸಿಲ್ಲ ಅಂತಂದ್ರೆ ನೀಟಾಗೆ ಬರಿತೀನಿ ನಾನು. I will write clearly here. See here, ER is equals to the square root of E1 square plus E2 square plus 2 E1 E2 into cos theta. Okay. Like that we can write the Resultant intensity formula. Resultant intensity formula. What is the theta here? Theta is the angle between, theta is the angle between the two electric field intensities. Two electric field intensities. Okay. So that is about the principle of superposition. Later we have to understand about the, what is this electric field lines here? Electric field lines. Electric field lines. So see here, we can say the first point is the imaginary line, imaginary line line drawn along the path, along the path followed by the unit positive charge, unit positive charge. And second one, we can say that no two lines intersect with each other. No two lines intersect each other. Okay. And this is second point. And third point, we can say that the tangent drawn, the tangent drawn at a point, to the line will give the direction of the electric field, direction of electric field. Is it right? And later we can say that, okay, larger the number of lines, stronger will be the field. ಎಲ್ಲಾದರೆ ಯಾವ ರೀಜನಲ್ಲಿ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ತುಂಬಾ ಹತ್ತಿರದಲ್ಲಿರುತ್ತೋ, ಜಾಸ್ತಿ ಇರುತ್ತೋ, ಅಲ್ಲಿ ನಿಮಗೆ ಏನಾಗಿರುತ್ತೆ, ಓಕೆ, ಫೀಲ್ಡ್ ಅನ್ನೋದು ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸ್ಟ್ರಾಂಗರ್ ದ ಫೀಲ್ಡ್, ಓಕೆ. ಸ್ಮಾಲರ್ ದ ನಂಬರ್ ಆಫ್ ಲೈನ್ಸ್, smaller the number of lines, weaker will be the field, okay. And later we can say that, see here, please observe that field lines will start from positive charge. And end at negative charge, ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಅನ್ನೋದು ನಿಮಗೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಹತ್ರ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ, ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಹತ್ರ ಎಂಡ್ ಆಗುತ್ತೆ. ದಟ್ ಮೀನ್ಸ್ ವಿ ಕ್ಯಾನ್ ಸೇ ದಟ್ ದ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ವಿಲ್ ನಾಟ್ ಫಾರ್ಮ್ ದ ಕ್ಲೋಸ್ಡ್ ಲೂಪ್, okay. Later understand about the electric field lines for important charges or important charge distribution. Electric field lines, whenever we consider a positive charge, the field lines always be diverging, So please have a look about this, Please have a look. This is the field lines for a positive charge. And whenever you take the negative charge here, the field lines, how the field lines will be means, it is a diverging and this is a converging, Field lines will be a converging line. Is it clear? And whenever we take the two combination of positive charge and negative charge, how will be the field lines? The field lines is as shown in the figure. So see here, the field lines will start from positive charge and end at negative charge. Like this, we have to think, Please make sure about this here. This is about the distribution of the field lines. About the individual charges and also system of two charges, equal and opposite charges. And similarly, we can also learn about the unequal charges, like charges, and unlike charges. But it is not so important, but this plays a very, very important. So why I am explaining to you. Now let us move on to the next concept. What is that? In the sense that is electric dipole. Here. What is this electric dipole here? Electric dipole is nothing but the arrangement consisting of two equal and opposite charges separated by a finite distance. Usually, standardly, we can represent the distance as 2a, because to avoid the what is it, complication while solving the problems based on a dipole. So see here, and later we have to understand what is the dipole moment. What is the dipole moment? Dipole moment, it is always be equals to the product of magnitude of the charge and the distance between the two charges. And see here, this dipole moment is a vector quantity, it is not a scalar, it is a vector, and is always directed from ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿರುತ್ತೆ ನಿಮಗೆ ಅಂತಂದಾಗ ಡೈರೆಕ್ಟ್ ಫ್ರಮ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಟು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. It is directed from negative charge to positive charge. So we can say it is a vector quantity. And later we have to understand. So see here, whenever we consider a dipole, and if we imagine a line passing through the charges is called as a axial line. We call it as axial line. And whenever we think about the line perpendicular and passing through the center of the dipole is called as a equatorial line. So we have to understand about the what is electric field at a point on the axial line, what is electric field on at a point on the equatorial line. So let us understand about this. What is the electric field along the axial line? It is equals to 1 by 4 pi epsilon naught into, we can say that 2 into P into R divided by R square minus A square whole square. We can write here. We can write 1 by 4 pi epsilon naught into 2 into PR divided by R square minus A square whole square. And please remember a condition here for short dipole. What is a short dipole here? When R is very large compared to distance, then we can say that R square minus A square is approximated as only R square. By simplifying this, we'll get electric field along the axial line due to short dipole. Is equals to 1 by 4 pi epsilon naught into 2 into P divided by R square. Okay. So sorry, R square, R cube. This is about the electric field due to dipole at an axial point. Okay. And please make sure about this. At an axial point, dipole moment and electric field will be in same direction. Will be in the same direction. That is the theta between dipole moment vector and the electric field vector is equals to 0 degree. Understood this point? So we can expect the questions based on this also. So at an axial point, the field what is the angle between the dipole moment vector and the electric field vector? It is always equal to 0, because dipole moment as well as electric field will be directed in the same direction. Okay. Now let us understand about the next one. What is the electric field intensity along the equatorial line here? It can be written as 1 by 4 pi epsilon naught into P into R divided by ಏನು ಬರುತ್ತೆ ನೋಡಿ ಇಲ್ಲಿ R square plus A square whole to the power of 3 by 2 ಅಂತ ಬರುತ್ತೆ. ಇಲ್ಲಿ R ಬರೋದಿಲ್ಲ. So see here, this is about the case. What is A? A is the distance from the center to any one of the charge. Okay. This is the general expression. Is it clear? Now for short dipole, short dipole. For short dipole, we can say that electric field along the equatorial line becomes equals to 1 by 4 pi epsilon naught into P by R cube. P by R cube. Okay. So please make sure about this, about the point here. And I will write a point for a short dipole. For a short dipole. For a short dipole, electric field along the axial point or axial line always be equals to 2 times the electric field on the equatorial line. On the equatorial line. Okay. Later we have to make sure about this. See here, for a point charge, for a point charge, ಒಂದು ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ನಾವು ಇಮ್ಯಾಜಿನ್ ಮಾಡಿಕೊಂಡಿದ್ದಾಗ electric field is inversely proportional to r square, and for a dipole, electric field is inversely proportional to r cube, Now let us move on to the what is electric field in general point or in general case at any point. So ನೋಡೋಣ ಇಲ್ಲಿ ಹೇಗೆ ಬರುತ್ತೆ ಅಂತ. Whenever we consider a dipole, let us say plus q and minus q, and let p be a point, let o be the center, and the line join the point p to the center will make some angle theta with the dipole moment. ಈ ಡೈಪೋಲ್ ಮೊಮೆಂಟ್ ವೆಕ್ಟಾರ್ ಜೊತೆ ಈ ಲೈನ್ ಅನ್ನೋದು ಥೀಟಾ ಆಂಗಲ್ ಮಾಡ್ತಾ ಇದ್ದರೆ, then how to write the electric field at some point p? We can write it as 1 by 4 pi epsilon naught into p by r cube into root of 3 cos square theta plus 1. P by r cube into root of 3 cos square theta plus 1. Okay, like this we can write the electric field intensity at any point, electric field intensity at any point, here, at any point. So like this we have to think and we have to analyze, each and every point related to a dipole, Now let us understand an important point, that is electric flux. Whatever the points we are discussing, all are important only. We should not neglect any point. So see here, what is this electric flux here? How can you define this electric flux? See here, the number of lines, the number of field lines, number of electric field lines, passing through the given area, the number of electric field lines passing through the given area, is called electric flux, So please make sure about this. How can we write mathematically the calculation of electric flux? So please observe the diagram carefully. Let us consider a uniform electric field, having the intensity E, and let us imagine a surface, here, and let the area always makes an angle theta with the electric field intensity, Then we can say that electric flux can be written as the dot product of electric field and the area vector, Please observe that carefully. For a given plane or for a given coil, for any given surface, area vector always acts normal to it. Suppose if this is a surface, and how will be the area? Area will always be acting normal to the surface. If the surface tilts like this, the area vector is directed as shown like this here. So based on that, we have to be very clear. So we can say that electric flux can be written as EA into cos theta. Is it clear? That is the flux passing through the given area. And please observe that if theta is equal to 0, what is the meaning of that? plane perpendicular to electric field or area vector parallel to the electric field ma. ಪ್ಲೇನ್ ಅನ್ನೋದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿರಬೇಕು, ಇಲ್ಲ ಏರಿಯಾ ವೆಕ್ಟಾರ್ ಅನ್ನೋದು ಪ್ಯಾರಲಲ್ ಆಗಿ ಇರಬೇಕು. ಅವಾಗಲೇ ನಮಗೆ ಥೀಟಾ 0 ಆಗುತ್ತೆ. Then we can say electric flux will become equals to E into A. E into A, we can say it is a maximum. We can say it is a maximum. Okay. And second case, see here, if theta is equals to 90 degree, if theta is 90 degree, then we can say that plane is parallel to electric field. Plane is parallel to electric field, or we can say that area vector will be perpendicular to electric field ma. ಸೊ ಚೆನ್ನಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ ನಾನು ಏನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅಂತ ಅಂದ್ಬಿಟ್ಟು, ಬಿಕಾಸ್ ಮೆನಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ವಿಲ್ ಗೋ ಕನ್ಫ್ಯೂಷನ್. ಪ್ಲೇನ್ ಪ್ಯಾರಲಲ್, ಏರಿಯಾ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್, ಇಲ್ಲಿಂದಾನೆ ಗೊತ್ತಾಗಬೇಕು ನಿಮಗೆ. theta is nothing but angle between the area vector and the field vector. Okay, then we can say that electric flux can be written as 0 anta barutte. We can say it is the minimum. Is it clear? I hope you understood the cases. You have understood this is the cases. These are all the cases which we have to study. That is when the flux will be maximum and when the flux will be minimum. Okay. So let us move on to the next point. That is torque acting on a dipole. What is the torque? On a dipole? Ma. So please observe this. Let us consider a dipole placed in a uniform electric field of intensity E ma here. So please observe this. This is a minus Q and this is a plus Q ma here. These two charges will experience a force. That is plus EQ, and this is a minus EQ. Therefore, first point we have to make that the net force acting on a dipole must be equal to 0. Net force acting on the dipole is equal to 0. Okay. And second point, we can say that what is the total charge on a dipole ma? Total charge on a dipole will become equal to 0. Total charge, because total charge plus Q and minus Q, if you add it, it becomes equal to 0. And third point, we can say that what is the torque? Ma here? Torque is represented by tau, and we can write it as in vector form. We can write P vector cross E vector. Torque is equals to P vector cross E vector, or in magnitude wise we can say P E sin theta. What is the theta value ma here? Theta is the angle between dipole moment and the electric field vector. Theta is angle between dipole moment and electric field vector. Okay. So what are the cases? First one, we have to understand that when theta is equal to 0. What is the meaning of that? If the dipole is placed along the field direction, then it will not experience the torque ma. Then the torque acting on the dipole will become equal to 0. Is it clear? And second case, when theta is equals to 90 degree, then what is the torque acting on the dipole ma here? If the dipole is placed perpendicular to the field, then we can say torque is equals to PE. Tau is equals to PE. So like that we can say it is a maximum. And torque, when torque is equal to 0, indicate it is a minimum torque. So these are the points which we have to understand whenever a dipole is placed in a uniform magnetic field. Net force 0, charge on the dipole is 0, torque is equals to vector form in magnitude form, and also when it will be maximum and when it will be minimum. Okay. So these are the things which we have to keep in our mind. Now later we have to understand about an important law, that is Gauss law. What the Gauss law states ma? ಚೆನ್ನಾಗಿ ನೆನಪಿರುತ್ತೆ, ಚೆನ್ನಾಗಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿರ್ತೀರಾ, ಇನ್ನು ಇವಾಗಲೂ ಓದ್ತಾ ಇರ್ತೀರಾ. Is it right or not? So what is the Gauss law? Gauss law says that the total electric flux, the total electric flux through a closed surface, total electric flux through a closed surface is equal to 1 by epsilon naught times the charge enclosed by it, charge enclosed by it, that is called as a Gauss law. So see here, mathematically we can write, see here, integral E dot ds, E vector dot ds vector is always equals to 1 by epsilon naught times the net charge. Is it clear? Or we can also write simply the total electric flux is equals to 1 by epsilon naught times the net charge. Is it clear? So this is how we can understand and we can learn about the Gauss law. And please make sure about this. If I consider a surface, which consists of, see here, 3 or 4 charges as shown like this. Then what is the flux through the Gaussian surface? We can write it as 1 by epsilon naught times the net charge, indicate Q1 minus Q2 plus Q3, okay, minus Q4 plus Q5. Like that, we have to consider the calculation of the net charge. If the charge is positive, take the positive value. The charge is negative, take the negative value. That's it, Is it clear? So that is how we can understand about the Gauss law. Later, understand about the few important points. That is, see here, linear charge density. What is the linear charge density? See here, it is denoted by lambda. It is always be equals to charge per unit length. It is measured as coulomb per meter. So for continuous charge distributed bodies, whenever a charge is distributed from one point to another point continuously without any gap, in that situations or in that cases, we have to learn about the, what is it, charge density. It is a linear, will give you one dimensional charge distribution here. So from this we have to understand that, the charge on a body is always equals to the product of charge density into length. Okay, while solving the numerical problems, we will come to know how to apply these formulas. And second one, we can say that surface charge density. What is the surface charge density? Denoted by usually sigma, and is equals to charge by area. Okay, therefore we can say that the charge can be written as charge density into area. Sigma into capital A. Similarly, we can move on to the, what is the third one? Volume charge density. Volume charge density. Denoted by usually rho. It is always equals to charge per unit volume. So we get the three-dimensional quantity. Therefore, we can write charge is equals to charge density into volume. Okay. So these are the important relations or important points which we have to learn for charge distribution or continuous charge distribution. Okay. Now let us see what are the applications of this here. What are the applications of Gauss law? Whenever we go with the applications of Gauss law, we can prove an important relations here. Relations are results. Applications. See here, first one. What is the field? Electric field due to electric field due to a line charge, my electric field due to a line charge, infinite line charge. So see here, whenever we consider the infinite charge distribution along one dimension, and if I consider a point P at a distance of r, you should measure it is a perpendicular distance. Then we can say that, nodili, electric field at a point is always equals to lambda divided by 2 pi epsilon naught r. And please observe this, due to infinite line charge, we can say that electric field intensity is inversely proportional to distance. So whenever we plot the graph by taking the distance along the x-axis and the field along the y-axis, then the graph appears as shown in the figure. Okay, this electric field due to infinite line charge. And second one we have to understand. What is the electric field. What is the electric field due to infinite sheet of charge, infinite sheet of charge. So please make sure about this here, infinite sheet of charge. See here, whenever we consider an infinite sheet of charge having the charge distribution, it may be a positive charge, it may be a negative charge, don't worry about that. If sigma is the charge density, and if I consider a point P, at a distance of r, then electric field can be sigma divided by 2 epsilon naught. And please make sure about this. ಏನು ಅಂತಂದಾಗ electric field intensity is independent of distance. It is independent of distance in case of sheet of charge. ಅಂದ್ರೆ ಶೀಟ್ ಆಫ್ ಚಾರ್ಜ್ ನಾವು ತಗೊಂಡಿದ್ದಾಗ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಂಟೆನ್ಸಿಟಿ ಅನ್ನೋದು ಡಿಸ್ಟೆನ್ಸ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗೋದಿಲ್ಲ. ಇಟ್ ಡಸ್ ನಾಟ್ ಡಿಪೆಂಡ್ ಆನ್ ದ ಡಿಸ್ಟೆನ್ಸ್. ಓಕೆ, ಸೊ ಲೇಟರ್ ಥರ್ಡ್ ಒನ್ ವಿ ಹ್ಯಾವ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಟ್ what is the electric field intensity due to a charged spherical shell due to a spherical shell here. So how can we write this? So here we have to understand the three different cases. First one, observe this. Whenever we consider a shell having the radius capital R, and whenever a charge is distributed, and the charge always resides on the surface, and if I consider a point P outside at a distance of R, so see here, first case, point lie outside the shell, So we can say that electric field outside is equals to 1 by 4 pi epsilon naught into, we can write Q is a charge on the shell divided by R square. 1 by 4 pi epsilon naught into Q by R square. This is the electric field at a point outside the shell. And please remember that R, what is R here? R is the distance from the center of the shell. Okay. Similarly, in the second case, electric field, otherwise we can write point lie on the shell. Whenever the point lie on the shell, see here, this is a charge, or this is a shell, and having a charge distribution as shown in the figure. And let capital R is the radius of the shell, then we can say that electric field on the spherical shell is given by 1 by 4 pi epsilon naught into Q divided by capital R square. Okay. And similarly, third case, what is the third case here? If the point P lie inside the shell, lie inside the shell. The point B lie inside the shell. For example, see here I will draw in this diagram only. The point B lie inside at a distance equal to small r. Then we can say that electric field inside the shell, we can prove it is equal to 0. It is equal to 0. Is it clear? So whenever you plot the graph, see here, this is a shell. Assume that this is a distance along the x-axis, electric field along the y-axis. Then the graph appears as shown in the figure. This is the radius. This is the radius. Small r will become equals to capital R. Inside there will be no field. Inside there will be no field. And at the radius the field will be maximum. Or on the surface the field will be maximum. Let us say here. And afterwards, as we move away from the surface, the field decreases as shown in the figure. Field decreases as shown in the figure. Okay, like this we have to analyze about the field intensity at each and every point due to charge distribution over a spherical shell shell. Okay, now let us understand few more points here. For example, whenever we consider a charge, which is placed inside the cube, then we can say what is the flux through the cube. Flux through the whole cube is always equals to, we can say, 1 by epsilon naught times the charge enclosed by it. Is it clear? And second case, observe this. Whenever we consider a charge which is placed at one of the corners, ಯಾವುದಾದ್ರೂ ಒಂದು ಕಾರ್ನರ್ ಅಲ್ಲಿ ಒಂದು ಚಾರ್ಜ್ ನ ಪ್ಲೇಸ್ ಮಾಡಿದ್ದಾಗ ಅವಾಗ ನಿಮಗೆ ಫ್ಲಕ್ಸ್ ಅನ್ನೋದು ಕ್ಯೂಬ್ ಇಂದ ಎಷ್ಟಿರುತ್ತೆ ಅಂತ ಕೇಳ್ತಾರೆ. ಸೊ ವಾಟ್ ಈಸ್ ದ ಫ್ಲಕ್ಸ್ ಥ್ರೂ ದ ಕ್ಯೂಬ್? ಪ್ಲೀಸ್ ಅಬ್ಸರ್ವ್ ದಿಸ್, ಹೌ ಐ ಆಮ್ ರೈಟಿಂಗ್. Flux through the cube is always equals to flux through the three phases. Flux through three phases, and it will be equals to Q divided by 8 epsilon naught. Whenever a charge is placed at the corner, then the flux through the given cube is always equals to Q by 8 epsilon naught. In the same case, what is the flux through each phase anta keltare. What is the flux through each phase? We can say it is equals to Q divided by 8 into 3, nothing but 24 epsilon naught. This is the value of flux through each phase. Okay, later we can understand if the charge is placed at any one of the phases. Whenever a charge is placed at any one of the phases, let us say this is one phase, then what is the flux? Through this phase, or flux through the cube? In order to find the flux through the cube, we have to imagine a closed surface. Okay, so please make sure about this. It is always equals to Q divided by 2 epsilon naught. Like this, we have to analyze each and every point related to the calculation of the flux. Sometimes they will be asking like this also. There is a cone in which the charge is placed as shown in the figure. Either the charge may be placed on the surface or inside the cone. Then what is the flux? Through the given cone anta keltare. Avaga enagutte, first we have to imagine a closed surface. Then what is the total flux to the closed surface, Gaussian surface? It will be equal to Q by epsilon naught. But I am asking only one half. Therefore we will get the flux through the cone is equals to charge divided by 2 epsilon naught. Is it clear? So like this, we have to understand and we have to analyze each and every point related to the electric field intensity and the ಸಾರಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಚಾರ್ಜಸ್ ಅಂಡ್ ಫೀಲ್ಡ್ಸ್. ಸೊ ಇದನ್ನೆಲ್ಲ ನೀವು ಓದಿದ್ದೀರಾ, ಕಲ್ತಿದ್ದೀರಾ, ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದ್ದೀರಾ ಎನ್ ನಂಬರ್ ಆಫ್ ಟೈಮ್ಸ್ ಅಂತಂದಾಗ the formulas will become familiar to you, so that we can answer the question, we can answer the questions easily in our CET entrance examination. Okay, so these are the important points, ma. Please go through it before going to start the numerical problems. Okay, so with this I am going to end the session. We will meet you with the next video by solving the numerical problems. Okay, so thank you very much. Don't forget to practice these formulas.